Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Rahman bin Abdul Rahim and I will present about the introduction of design water supply proposal on service reservoir project. Thank you for Dr. Roslinda binti Seswaya for having me the opportunity with my members to introduce our proposal. So the timeline of our proposal, that will be me, Nur Ahmad bin Rahim, as introduction and background study presenter. For proposal on task 1, there will Muhammad Izzat Aziz bin Muhammad Azan and Muhammad Arif Syafiq bin Muhammad Syafi'i to present it. And proposal on task 2, there will Muhammad Zulhas Shah bin Badri and Zubair Awam bin Syahrul Bashar. Background study, service reservoir are the essential of the water distribution network. The device is powered and the configuration of pipe elements depends on service reservoir that supplied it. We cannot ignore the effect of not getting the service reservoir because it will harness microorganism growth in water. Then, various researchers are approaching statistically to determine and assess the capacity of the position and operation of the pipe elements, whether or we call tanks. So, the goals is on decision of service reservoir with new details of good water quality. Then, I will pass to the Muhammad Izzat Aziz bin Muhammad Azan to explain about the proposal on task 1. Thank you.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Izzat Aziz bin Muhammad Azan. So, I will present about the purpose, required volume of the service reservoir. So, basically our apartment consists of one block that has 148 unit. So then we want to find the peak flow factor. Before we get the peak flow factor, we must find the population equivalent. So first of all, we need to 148 we times by 5 capita per unit. So we get 740 people for population equivalent. This value of 5 capita per unit we get from the MASMA 1228. We get from MASMA 1228 that require the resident by 5 capita per unit. So so we get the population equivalent 740 people. So after that we can find the peak flow factor. So peak flow factor 4.7 we times by 740 we divide into 1000 the power of negative 0.11. So we get 4.86 for the peak flow factor. So for the next is we want to find the design for a water supply serving for 740 people. So first of all we need to find the maximum daily flow rate, that is QM. Peak flow that we get 4.86 we times by 1500 liter per day per capita times by 740 people. So we get 5.4 times 10 the power of 6 meter cube per day. So if we get the QM, we can find the V peak. V peak that's 0.25. Why we use 0.25? Because we taken 25% of the maximum daily demand, and then we time by 5.4 times 10 the power of 6, and we get the V peak is 1350 meter cube. Okay, that's all from me. I will pass to my friend. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Syafiq bin Muhammad Syafi'i. So I will continue the calculation from task 1. Okay, so we need to find the volume for firefighting. So the fire flow, we use 4,100 liter per minute. This value we get from JKR standards, and the firefighting must be maintained for at least 9 hours. So the volume for firefighting was 2,268 meter cube. So next we need to identify the emergency storage. So in this calculation, we need to use the population equivalence and the average daily demand. So the volume for emergency storage was 1,110 meter cube. So finally, we need to the required volume for the reservoir is, we need to sum up all the volume from volume peak, volume firefighting, and volume emergency. So the total was 4,728 meter cube. So that's all from me. Calculation from task 1. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zul Ashraf Bibadri and I will present for the task 2. Okay, for the task 2, we have been given a task on to determine the discharge in each of pipe based on the figure B. So the detail for the pipe is shown as in figure 1. So firstly, we have to calculate the value of K of each pipe parameter. So the formula is K equal to 10.7 L over CHW to the power of 1.852 times D to the power of 4.87. So after that, we have to find the value of HF by using the formula of K times Q to the power of 1.852. And then after that, we have to calculate the difference between flow rate of each pipe by using the formula of summation of HF divided by N times the summation of HF over QA. So for pipe 2 in loop 1, so we have the difference of flow rate is the difference of flow rate in Q1 is minus for the flow rate of Q2, and for the pipe 2 in loop 2, so the difference of flow rate is calculated by the difference of flow rate in Q2 is minus by the difference of flow rate in Q1. Okay, for the next part, I will pass to my friend, which is Zubair Awam. Thank you.
Hello, my name is Zubair Awam Bashar. My metric number is 170165. And right now I'm going to explain the iteration process of the piping system for the task 2. So, based on the explained formula from my previous members, we will use the Q assumption of the individual pipe and to obtain the head loss. We will use the value or negative value for the each loop using direction of anti-clockwise for the negative, then counter clockwise for the positive. And this is the value for the total of the head loss. And we will use the head loss over the Q assumption and find the total, and we will use the previous formula to obtain the value of change in flow rate. The change in flow rate is still huge, and we will make some correction for the next iteration. The new flow rate will be added with the changes, and the iteration process will be proceed until the value of the changes is negligible, which nearest to the 0 as shown in this iteration 4. And this is the result of the iteration process. The arrow diagram, the arrow will be the direction and the value will be the flow rate in meter per second.